Okay, so our next lesson is about tangents. We're going to go ahead and start this lesson by crossing out a couple of these problems. Don't cross them out all the way, but just mark them off for now. I taught something in a different order last year and I forgot that I did it that way. So there's a couple problems we won't know how to do yet. So go ahead, we're going to just X out number 1. Again, don't cross it out all the way. Number 1 and number 5 and number 6. So you can go ahead and cross those out. We'll come back to them once we learn chain rule. But for now, we're gonna skip those. Okay, so the concept of tangents is pretty straightforward. It's combining a concept that you just learned with first derivatives and combining it with a concept that you learned a long time ago, which is point slope form. So tangent lines are functions. So if we're talking about a tangent line, let's look at this example. If I were to graph this function, and try to figure out what it looks like, a tangent line. So here is our function. And it's asking me what the tangent line at x equals 1 is. So a tangent line, I'm going to try to zoom in closer, sorry. So this is the value x equals 1 right here. This is that point, and a tangent line is where you have a straight line that follows the slope as closely as possible and just barely touches that point. It doesn't cross a long way through the function. It just grazes the equation on its side. So I can show you guys a demonstration with a ruler in class if y'all remind me. But the tangent line barely skims the edge. So basically what we need to do in order to figure out the function of that tangent line is we need to figure out what the slope is at that instant point. And if we're looking for the instantaneous slope or the instantaneous gradient, we need to take the derivative. So our first step is to find the derivative. So here, y prime, y prime, our derivative would be negative 3x squared plus 2x. And remember that constant goes away. So we have negative 3x squared plus 2x. And from here, what we do is we plug in that value of 1 because we want to know what the slope is right there. So y prime of 1 is negative 3 plus 2, which is negative 1. So we know that the slope of this line is negative 1. So our slope is negative 1. Now the next step we need to figure out is what is the equation of a line. Now we have two ways to find a line. We can find the y-intercept or we can use point slope form. So you'll remember that the slope formula you learned for point slope was y equals starting over, my bad. Y minus y1 is equal to m times x minus x1. This is the point slope form. So now the only difference is instead of m, we're going to put in our derivative. So now it is y minus y1 is equal to dy dx times x minus x1. Okay? So all I have to do is plug in the coordinates of that point. So I know that the x value is 1. So in order to figure out what the y value is, I plug it into my original equation. So I would have y is equal to negative times 1 cubed plus 1 squared minus 4, which is negative 1 plus 1 minus 4, which is just minus 4. So now my final answer for that equation would be y minus -4 is equal to -1 times x minus 1, which would be the same thing as y plus 4 equals -x plus 1. If they ask you to put it in point slope form, this is acceptable. If they don't ask, then you can leave it like this. Or if they ask you to put it in slope intercept form, then you would just solve for y. So we would get y equals -x minus 3. Both of them are acceptable. I know that's kind of scattered, so I'm going to do the next one without graphing the picture and just do it on this tangent notes page. Okay. So next, scroll down. Let's try this one. So we have here, just a reminder, our formula is y minus y1 equals the derivative at that value times x minus x1. Okay, so I'm going to start by finding the derivative first. So dy dx is equal to 2x. And they want to know what it is at x equals 3, so I'll plug that in. 2 times 3 is 6. So I know my slope is 6. But I also need to know what my y1 value is. So that means I have to plug in 3 to this original equation. So I would have 3 squared minus 2, which is 9 minus 2, which is 7. Okay, so now I'm going to plug in everything I know into this whole handy dandy equation up here. So I have y minus 7 is equal to 6 times x minus 3. And that's my answer. Okay, so number 4 is the last one that you need to try. I encourage you to try it on your own. So go ahead, pause the video and try it out, and then come back and check your answer. Okay, so in order to figure this one out, hopefully you took your derivative. So your derivative would be dy dx is equal to negative 3x squared plus 8x. When I plug in -1, I get negative 3 times positive 1 plus 8 times -1. So that's negative 3 minus 8, which is negative 11. So I know that my slope equals negative 11. Okay, and then the next step is to figure out what my y1 is, which I do by plugging into my original equation. So I have y equals negative 1 cubed plus 4 times -1 squared minus 7, which is equal to positive 1 plus 4 minus 7, which is -2. Okay. So once you have that y is equal to -2, now I can plug it into my tangent equation formula. So I have y minus y1, which is -2, is equal to our slope times x minus our x1. Okay, and I'm going to simplify that. That's y plus 2 equals -11 times x plus 1. And that's that. Hopefully I didn't make any math errors, but if I did, just let me know tomorrow. We can go over it again. But I'll go ahead and post the Delta Math in case any of you want to get started over the weekend, but make sure that your priority is the pre-existing Delta Math equations. Those are due on Sunday, okay?